Okay, so welcome back. Okay, so um, in my videos, I'm trying to talk slow. So if you find it too slow, then you can always adjust the playback speed if you want to make it faster. Okay, so this we only have 5 more weeks of lessons. Okay, so we're going to study after the series. So we're going to study exponential, logarithmic, radical, and rational. These are all different type of functions. Exponential is review from algebra 1, exponential growth, exponential decay. So I'm going to touch on that, but logarithms are very important. So when we study each one of them, first we're going to do an introduction, okay? And then maybe we're going to study the laws, the properties of each one of these, and then we're going to graph using transformation. Okay, so we're going to translate to the right, to the left, vertical stretch. We're going to do all of that again. So we're going to use transformations. And then the last is we're going to solve equations. We're going to solve exponential equation, logarithmic equation, radical equation, and rational equation. Okay, so let's start with exponential functions. Okay, so it's a review. Like I said, if you have your notes in algebra 1, then you can get that review. Exponential functions. Okay, let's start. Exponential functions. So we are studying before, like x squared, right? So we know that x squared or x cubed, okay, they have exponents, but we don't call them exponential. Okay, they are actually polynomial functions. Oh, that's one more thing we have to study, polynomial functions. Okay. Oh no, we're already finished with polynomial functions. We already graphed it and everything. Okay, so we're done with that. The bounds and the cross. Okay, we know that. Okay, so not anymore. We're done with that. So these are polynomial functions. So you know how to graph this. Okay, you know how to graph that. That's a parabola. So what we're going to study with exponential functions is this becomes the base and x becomes the exponent. Okay, so these are exponential function. This is the base, that's the exponent. So instead of x to the 3, we're going to study 3 to the x, okay, or 4 to the x, or 5 to the x. So that's a y or f of x. When it is like this is the base and that is the exponent is x. When the base is bigger than 1, like 2, 3, 4, 5, okay, so the form of exponential is b to the x, okay. So when b is like this, that it's bigger than 1, we call that an exponential growth, okay. Exponential growth when b is bigger than 1. What about if the base is smaller than 1? Let's say 1/2 to the x. Let's just put a parenthesis, or 2/3 to the x. Okay. Or let's say, why do we put parentheses? If you have 4/5 to the x, you might think that you're only raising 4 to the x. Instead, you're raising 4/5. So when this is smaller than 1, okay, and that is called, but bigger than 0, it has to be positive. So this is called, so exponential decay. Exponential decay. Okay, when b is between bigger than 0 but less than 1. Okay, it's not, again, if the base is bigger than 1, it's an exponential growth. If it is smaller than 1 but bigger than 0, meaning to say positive, smaller than 0, then it's an exponential decay. It's not because it is a fraction, okay? Because if you have, let's say, 7/3, that is a fraction, but it's still bigger than 1, then that is still an exponential decay, growth, exponential growth, okay? These are all exponential decay. Now, what is the graph of exponential growth? Okay, so I'm just going to review that. So if you have your x and y axis here, if it is an exponential growth, okay, so you're going, I hope you remember, you have your asymptote, meaning to say your graph will not hit or will not cross that, okay? And of course you're going to have your y-intercept is always on 1, because when x is 0, these are all equal to 1. 2 to the 0 is 1, 3 to the 0 is 1, 4 to the 0 is 1, 5 to the 0 is 1. So all of these have the same y-intercept, 1. And then you're going to get, okay, when x is 1, okay, so 2, 3, 4, 5. Okay, so you're going to have this shape going up, okay, and this one will approach your asymptote. It's going to go closer and closer, but it's not going to touch it. So it's increasing as x approaches positive infinity, y approaches positive infinity. But the decay, okay, so you still have your asymptote here, and your y-intercept is still 1 all the time. Make x 0 to find the y-intercept. You make x 0. So the answer will always be 1. Okay. So the y-intercept is always 1, and it's going to decrease until it approaches 0. So this is the two shape of exponential. It's either growth or decay. So we're going to graph this, okay? We're going to graph this one here, and we're going to transform them, all the transformations, in the next video.